Giovanni, an Italian poet and a very old-school kind of guy, wants to send a letter to his sweetheart. The only problem is, his swain lives in the neighboring kingdom 250 miles away. He visits the local carrier pigeon salesman and purchases the fastest pigeon in all the land. Giovanni's quite impatient and wants to know when the pigeon will reach his paramour. To figure this out and play medieval matchmaker for Giovanni, we can use constant rate of change. When something has a constant rate of change, one quantity changes in relation to the other. For example, for every half hour the pigeon flies, he can cover a distance of 25 miles. We can write this constant rate as a ratio. For ratios, it's always a good idea to state both units in whole terms. Since we don't want to change the ratio, we multiply the ratio by its multiplicative identity. In this case, that means multiplying both the numerator and denominator by 2 to get a whole number in the denominator. And, just like with fractions, you should always write ratios in lowest terms. Simplified, the constant rate is 50 miles per hour. Let's help Giovanni figure out where his pigeon will be after a certain amount of time has passed. We can create a table using different values for time to see how much progress the pigeon has made. We know the pigeon flies at a rate of 50 miles per hour. So, after 1 hour, the pigeon will have flown a total of 50 miles. To find out how far the pigeon will have flown after 2 hours, we just have to multiply the rate by 2. If the pigeon flies for 3 hours, we can simply multiply our original rate by 3 to find out that the pigeon will have traveled 150 miles. We can continue this process, filling in our table as we go. Okay, looking good. But to get an even better understanding, let's graph the data from the table. Let the x-axis represent the elapsed time in hours, and let the y-axis represent the distance in miles. Each x-y pair represents a location on the graph. Just like x is an independent variable, the number of hours is the independent variable in this example. So the total distance, y, is the dependent variable. Now plot the points from the table onto the graph using the ordered pair, hours, and miles. Notice how the graph is a perfectly straight line. Notice that for every hour, the pigeon flies an additional 50 miles.